Let us now discuss and understand Young's double slit experiment setup. This is an experiment which is used to demonstrate the interference of light in laboratory. Here you can see this is a typical setup in which there is a screen, and at a separation capital D from the screen, there is a slit plane in which there are two rectangular slits cut. This slit plane is like this. I am drawing a perspective view in which there is like a cardboard in which there are two rectangular slits which are cut at a separation D. In this situation, we have drawn the cross-sectional view of this slit plane, and before this slit plane there is a single slit edge which is called source slit. And on this slit plane, when a light beam is incident, then only those points or secondary wavelet which are passing through the slit will produce wavefront after this slit and illuminate the two slits S1 and S2 on the slit plane. And again, as S1 and S2 are separated by equal distances from the source slit, these two will oscillate in same phase and will produce their own wavefronts afterwards. And here we can see the light waves from slits S1 and S2 will reach on a screen and produce interference effects. Here if we analyze it carefully, we can see that at the center of screen O, the light wave from the slits S1 and S2, which are assumed to be of cylindrical wavefront, are reaching point O by covering equal physical paths. So here the path difference is equals to 0. If path difference is 0, at this point the two waves will interfere constructively. And here if we consider I0 is the intensity due to each slit S1 and S2 on a screen, then here we can say at the center of a screen the resulting intensity will be 4I0 because the constructive interference is taking place due to 0 path difference. If we move slightly away from the center of a screen, there will be a point where you can see the path of S1 is less and S2 is relatively more, and here the path difference will increase, and say if it will become lambda by 2. If lambda is the wavelength of incident light onto it, then in this situation at this point destructive interference will take place and the intensity of light will be 0. Then again after some distance, when the path of S1 is further reduced and that of S2 is increased, then here path difference we can write as lambda, where again constructive interference takes place and the intensity is 4I0. So in this situation at 0 lambda by 2 lambda and 3 lambda by 2 again destructive interference takes place, and here we can see alternatively bright and dark regions are obtained on a screen where intensity is 4I0 and 0. And similarly below the center of a screen also there will be bright and dark zones with 0 intensity, 4I0 intensity and so on are obtained. Such regions of equal intensities on a screen are called fringes, and this whole pattern of variation of light which is obtained on a screen we call fringe pattern. And a typical fringe pattern we can see here only. You can see in this fringe pattern the central fringe is bright with the 4I0 intensity, and close to it the neighboring fringe is dark and then bright and so on. Such fringes are obtained, and this is the fringe pattern which is the resulting effect of interference of light coming from the two coherent sources S1 and S2 on the slit plane. Similar to this, even if we remove the source slit, direct light is incident onto the slit plane. Theoretically, interference pattern can be obtained which is similar to this, but practically it is difficult to keep the two sources in same phase by a single light beam. But certainly we can develop a direct light YDSE setup in which there are two slits S1 and S2 on which directly light is incident normally. so that the two oscillates in same phase, and on a screen fringe pattern is obtained if this d, this small d. So theoretically again here fringe pattern is obtained, and such a setup we call direct light Young's double slit experiment setup. If we talk about the variation of intensity on a screen, here if the screen center is plus x and this minus x, we can plot the variation of intensity on a scale between intensity and the x position. If this is the screen center, at the center of the screen the intensity will be 4I0, and on the two sides it will gradually decrease, and this is the point where a dark fringe is obtained. Here you can see this fringe will be the dark fringe where intensity is getting 0, and again a bright fringe is obtained and a dark fringe, alternatively these are obtained. So this is the variation of intensity on the two sides of a screen with corresponding bright and dark fringes alternatively on the two sides of a screen.